So we'll be looking at catching. So starting from the first task, we're told to create a class basic catch that is going to inherit from base catching and is a catching system. We must use self.catch dictionary from the parent class base catching. Then we have to create this method to assign must assign to the dictionary self.catch data the item value for the key. That is, we assign this item to this key. Then if key or item is none, we should not do anything. Then for the get one, I get this one is for the retrieval, must return the value in self.catch linked to the key. And if key is none of the key doesn't exist in self.catch, we should return none. So this is I just created a different file for the parent class. Here you see that the catch is an empty dictionary, and then this is for printing the catch. And then I guess this method here is just in case if you forget to implement it in the class that we are told to implement. So it's going to raise not implemented error, same thing with the get method. So let's get started. So mine is in a file name task 0. So I've got my docs, imported the module, and then I've created the class first in first out catch, and then I've created the constructor. I've called the super of the parent method, which is base catching. Don't forget that I imported base catching here, and then I've already defined the function, and then passed in and annotated the function, something with the get method, and then this is the main file that was given, so I just added it here. So let's get started. For the type first. Space. So the put method is just used to add value to a catch, so we don't necessarily need to return a value. So we just say self.catch data, and then we pass in key, saying that this key is equal to the item. And we check out this pass, and then the get method, we are supposed to return none, or if the key is none or does not exist. So if you just say self.catch data dot get key, we pass in key. So this get method, what it's going to do is like it has an inbuilt error handler. Since we're using this method, if key is non-existing or is none, it's going to return none. So that is it for this one. Let's just test and run. Did I say test and run? Save and run. Basic catch is not defined. Oh, My bad. This is supposed to be basic catch. Supposed to be basic catch, yeah. So there you have it. Moving on to the second. So the second one, this time we are going to create first in, first out catch that is going to inherit from the base catching class. So must you use the self dot catch data dictionary from the parent class, and we have to again create a method, put methods, then we follow all these requirements, and then the self method too follow all these requirements. So let me not just go ahead and read it out. So let's get started. As you already know, I have my base catching in another file, so I can have space for this one. Should I say space or clearance? So I've imported the base catching, and I've imported everything I need from typing for the annotation. I've given the annotation for both methods. So of course we've called the super function of the parent class to initialize the attribute behavior common to both classes. So for the put method, which is used for adding a data to a catch, we are going to check if key is not none and item is not none, because we are told that if key is none and item is none, it should do nothing. So we are going to say if key is not none and item is not none, then we will do something. So what do we want to do? First, we want to check if the length of the catch data, that's the dictionary, the length of self of catch data is greater than or equal to the max item, that's the max item, the class attribute declared in the parent class, which is, I think, is equal to 4. I think the max item is 4. So if the length of self dot catch is greater or equal to the max item, what do we want to do? So what we are going to do is to let me see. Well, we can delete the first key in the catch with its value in a dict. One way to do it is to first turn the dictionary to a list and then save it to a variable, and then we retrieve the first key and then use pop method to isolate it and then delete it, just like this. We say, let's say catch data is list. That's first we convert the dictionary to a list of keys so that we can be able to grab the keys and not the value, the keys. Dot keys, because the keys is what we need. And then we pick the first key by index. We say first key. Remember that we've already turned this into a list, so we can be able to pick the key by index. That is, we pick the first key, and then now we are going to use the pop method to isolate the item. remove the item from the catch data. So we say pop dot catch data, sorry, self dot catch data dot. Now we use the pop method and then passing the name of the key, whatever the name is, which is the first key that we used the list. We converted to the catch data, which is the dictionary, to a list, and then we retrieve the keys and saved it to catch data, and then this catch data we retrieve the first key and save it to first key, and then inside this catch data we remove the first key using pop method. So next thing we do is to print notice that this key is about to be, or this key is deleted. We use the format method, then we pass in first key. I guess I have to be sure that this is deleted, so I just call delete on the first key, and then for the get method we are just going to retrieve the catch. So we just do the same thing we did for the previous task. We just say return catch data. Don't forget that this dot get method is going to return none if the key is non-existing or is none. So let's save and run. Hope there is no typo this time. Okay, let me see. So I forgot to, yeah, feeling me. Forgot to add the key to the catch. So now that we've gotten it, we've corrected it, we should be fine now. Yeah. So the task 2 is last in first out, to create a class default catch that we inherit from base catching as usual. Then the put method, if key or item is none, should do nothing. Number of items in catch data shouldn't be higher than that. In base catching, that's mask items. Then if it's greater, we should discard the last item in the catch and display this message. And then the get method, if key is none or key doesn't exist in the catch data, we should return none. As you already know, I have my parent class base catching inside this file, and let me fast forward and do this. Just set it, then we can get started. So let's continue. My docs is there. I've imported base catching, imported all this for annotation, created the class default catch as inherited base catching, created the constructor, and then define the function with the annotation and docs. Same thing with the get method. So where's my arrow? Okay, so first thing is to call the super function of the parent class to initialize the attribute behavior common to both classes as we did before. So super and then we are going to create an empty list. This empty list, we are going to use it to store the keys in the order in which they are added to the cache. Self.queue. So next thing we do is to in the put method, since we are told to that we should return if the key is none or item is none. So we are not going to catch, we are just going to say if key is none or none or item is none, should just return. And then if there is a key, an item as well, we have to catch the key. So we say self dot catch data, and then we catch the key. Then we will also add the key to the self.queue list to keep the track of the order of the cache data. But before we add the key to the list, we first check if by now we have exceeded the maximum number of items that can be cached. So as in, whenever we catch an item, we have to check if the length of the self.cache data is now greater than the maximum number of items that can be cached. So we say self.catch base catching dot max items. Yeah, so if for real that the length of cache data is now greater than that of the max items, then we are going to check that the self.queue list is not empty in order to verify that there are items in the queue before trying eviction. So we say self queue, if it's not empty, if the self.queue list is not empty, we are going to remove the last item from the list and assign it to the last variable. We just say last is equal to queue dot pop. So this is going to pop the last item. And then the last item represents the key to be removed from the cache. So next is we are going to delete the key value pair from the cache. So we call delete and then self.catch data, and then we pass in the key, the name of the key. This way it's deleted, and then we print that we've deleted this. So this way we have removed the key from the list and removed the key value pair from the self.catch data, thereby maintaining the order of the last thing first out. So whenever we catch a key and this item, we will grab just the key and then add it to the self.queue list by checking if the key does not already exist in the list. So we say if key not in self.queue, if the key does not exist yet in the queue list, then the new key will be added using the append method. Then we say self dot q dot append, and then we pass in key. Oh. And then we pass in key. But if the key exists, if it is in existence and is already in the list, we are going to check if the key is the last in the list. So we check if the key is the last in the list. If it is not the last in the list, we are going to remove it from its former position. So we say Q, did I get it right? Q. Oh, man. So we say Q dot remove, and then we pass in key. And then once we remove it from its former position, we are going to add it back at the end to maintain orderliness. So we say self dot q dot append. Again, we pass in the key. And what else? What else is there? Okay, let's go to the get method. So we are just going to return self dot catch data dot get key. Again, the .get method is going to return none if the key is none or the key is non-existent. So let's save it and run. So for the third task, we are told to create a class called LRU catch, that is list recent reuse. It's going to inherit from base catching as usual. So we have to follow all these requirements. We discard the least recent reuse item in the put methods, and then if the key is none or key doesn't exist, we should return none. So you can see right here, as usual, I've made necessary importations, created the class, and in the constructor I've already called the super and created an empty list queue, and then define the function with annotations. The method is annotation. So let's just get started. So in list recently used, when a new item is added to the catch or an existing item is accessed, that is used, it is marked as the most recently used. When the catch becomes full and needs to evict an item to make space for a new one, the least recently used item is removed, which has not been accessed for the longest time. So I don't know if I've said it before, this queue, you're going to use it to store the keys in the order which they are added to the catch, and then the super function is to initialize the attribute behavior to both classes as usual. So let's start. So if key is none or item is none, we should just return without doing nothing as usual. If key is none for item is no, we return. And then if there is a key and item as well, we catch the key. So self dot catch data is equal to item. Then we will also add the key to the self.queue list to keep track of the order of the catch data. But before we add the key to the list, we have to first check if by now if we have exceeded the max items that can be cached. So we check if the length of self.catch data is greater than the base what am I right? The base catching dot max items. So once we check if the length of the catch data is greater than the max item, if it's greater, first we are going to grab the first key in the queue because it is the least used catch data. So we say first key, I just say first is equal to self.queue, and then we grab the first item in the queue. That is if self.queue is not empty. If it's empty, just turn none. Then again, after checking for this, we check if the first key, which is the least key used, exists. If it's in existence, check if the first key is in existence. Then if it exists, we are going to remove it from the queue. So we say self.queue.pop, which is the first one. We remove it, and then after removing it, we are going to also remove it from the catch data as well. So we use the delete key self.catch data, and then we pass in the key, which is first. We already grabbed the key there. So, and after deleting it, we are just going to print it. Say this. Passing first. Then now every time that we add a key value pair to the catch data dictionary, we will add the key to the queue for orderliness. But first we check if the key already exists in the queue. So we check if key is not in queue in self.queue, not in self.queue. What do we want to do? If it's not, we add the key to the end of the queue. We say self.queue.append. Append is going to add to the right side, that's the end of the queue. And then, but if the key already exists, so if it already exists, we check if the key is the most recently used, that is the last in the queue. And if it's the last in the queue, we are going to do nothing. But if it's not last in the queue, let's type this down first. If self dot queue is the last in the list, if it's last in the list, we don't do nothing. But if it's not last in the list, so meaning that we have to move it to the end of the queue as the most recently used by removing it from its current index or position. Say self dot queue dot remove key, and then we move it to the end of the queue as the most recently used. Then we say self dot queue dot append, and then we pass in key, and then we are going to go to the get methods and do what we have to do. Okay, so we are going to grab the card. So first thing to do is first we try to retrieve the item associated with the provided key from the cache data. So we just say item is equal to self dot cache data dot get key. Then we confirm that the item's key exists in the cache. So we say if item, that is if it does exist, if the item exists, we need to check the position in the queue, and we want to ensure that the most recently used items are at the end of the queue. If the item is not at the end of the if it's not at the end of the queue, then that is if it's not the most recently used, we will update the order. So moving on, we check if the item's key is not the most recently used in the queue. It's not the most recently in the queue. We check, say self dot queue, check if the last item is not the most recently. If the item's key is not at the end of the queue, we need to update its position in the queue. So to do this, we are going to remove the key from its current position in the queue. So we say queue dot remove, we pass in key, and then secondly we add the key to the end of the queue to mark it as the most recently used key. Self dot queue dot append, we pass in key. After this, we just return the item to the caller. Yeah, okay, I think this should do it. I hope there's no typo. So this is the what we're supposed to use to test it. I just added it to my main. So let's run this. Typo, I'm aware. Okay, we're line 26. It's line 26. Again. Okay, that's it for this. So for the fourth one, we are creating a class called MRU catch. That's most recently used. So for this one, we do the same thing, and then in the put method, we're going to check if the number of items in self.catch is higher than that in the max items. If it is, we are going to discard the most recently used item using the MRU algorithm, and then we print out this. So task 4. So I've already prepared all of this, and then excuse me, let's go straight to the put method. So first, as usual, we check if either the key or item is none, and return if it's none. So if key is none or item is none, we just return. Again, we catch the item using the provided key. That is, if it's not none, catch the data. So we catch the item. So then we check if the catch has exceeded its maximum capacity as required. If length of self dot catch data is greater than base catching dot max items. So if the catch is over the capacity, we need to make room for the new item. So we say if self.q, that is, if self.q is not empty, if we have items in queue, which means there are catch items to maintain the most recently used policy, we need to remove the least recently used item, which is the last item in the queue. So we say last is equal to self.q.pop, and then we remove the corresponding item from the catch data. So we say self.catch data, then we pass in last. So again, we print out the message saying that we've discarded this. And then we pass in last. Again, so now we need to update the queue to reflect the most recent access. So we say if key is not in self.q, that is, the key is not already in the queue, so we add it to the end to indicate that it's the most recently used. So we say self.q.append key. Else, if self.q, that is, if the last index in the queue list is not the key, self.q last index is not the key. So the key is in the queue, but it's not at the end. It's not the most recent. So we are going to move it to the end to maintain the MRU policy, that's most recent used policy. And then first we remove the key from its current position in the queue. So you self dot queue dot append, and we pass in key. Then once we're supposed to remove it first, yes, yeah. First we first remove it. So once we have removed it, and then we are going to add the key to the end of the queue to mark it as the most recently used item. Now this is where we use the append. And what else am I? Okay, and then in the get method, we are going to first attempt to retrieve the item associated with the provided key from the cache. So we say item is equal to self dot cache data dot get key, and then we check if the item exists in the cache. If the item exists, we need to check its position in the queue, that's the index in the queue. And then in the most recently used caching, MRU caching, we want the most recently used items to be at the end of the queue. If the item is not at the end of the queue, that is, it is not the most recently used item, we are going to update the order. So we say if the item is existing, we check if the item's key is not the last, that is, if self dot queue is not equal to the key, actually if it's not the last in the queue. If it's not the last, what we want to do is to again remove the key from its current position in the queue. So we say self dot queue dot remove, and we pass in key. And then again we add the key to the end of the queue to mark it as the most recently used item. Self the queue dot append, and we pass in key. And then finally we return the item to the caller. So we just say return item. Hope I did a good job at explaining this. So let's save and run if I don't have no typo. Yeah. Okay, my bad. So there. So so for the last one, to create this one, least frequently used cache that we also inherit from base caching, and if key is none, we should do nothing. If the number of items in self.cache is higher, we are to discard the least frequency used in the item using the algorithm. And if you find more than one item to discard, you must use the RLU algorithm to discard only the least recently used. Excuse me. So, and then we must print out this. So that's 5. Yeah. So as usual, I've put this out of the way, created the class, and inside the constructor, we've called the super to create attribute that is an empty to, so that we can, what am I saying? The the child class can have the same logic with the parent class, and then we create an empty list that is going to store the keys in the order which they are added to the cache, and then the self.counter is an attribute that is going to be is an empty dictionary that is going to store the count frequency of each key to implement the LFU. So this is the print method, and this is the game method. I've defined the function. Then we are going to have three functions in this one. So the third one is going to be able to reposition an element within the queue to currently account for the least frequently used principle. So let's start. First, we validate the input. We check if the key or item is none and return early if so. So we check if key is none or item is none. If they are none, if any of them is none, we return. So doing this is what it does is to ensure that invalid or missing data is not added to the cache. So the next thing is to proceed to cache the item using the provided key. So we say self dot cache data is equal to item. So next is to count the frequency. We have to maintain a counter dictionary that keeps track of the frequency of each key in the cache. So we start by first retrieving the count frequency of this key in the counter dictionary. So we say key count is equal to self dot counter dot get key. Again, we are going to check if the key exists in the counter dictionary. So we say if key count is not none, that is if it exists. So we are going to update the count of this key by 1. Self dot counter, then we pass in the key and increment it by 1. So this indicates that the key has been used once. Next, if it doesn't exist, we are going to initialize it to 1. Let me take this back. Say else. If it doesn't exist, we initialize it to 1. Self dot counter key is 1. So this indicates that the key has been used once. So next is we manage the cache capacity. So we check if the cache has exceeded its maximum capacity, that's the max items. So we check if the length of self dot cache data, what am I doing? Cache data is now greater than the base caching dot max items. So if the cache is over capacity, we need to make room for new item. So we are going to retrieve the first key in the queue, which is least frequently used. So we say first is equal to self dot queue, get the first in the list, and if self dot queue is empty, we just return none, making none. So if the queue is empty, it sets first to none, and then next is discarding the LFU item. If a first key is found, indicating that the cache is over capacity. So if we check if the first key is found, we remove the first key from the queue. So self dot queue dot pop, remove the first key from the queue, and then also from the cache data, say delete self dot cache data, and we pass in first, and also we delete it from the counter. Self dot counter first. So what this will do is it is effectively discards the least frequently used item from the cache. So after doing this, we are going to print the message to indicate that item is being discarded or item is discarded. Discard. And then we pass in first. So next we check if the key is not already in the queue. That is here, if the length of the cache data is not yet greater than the base, is not yet greater than the max items, so it's going to skip this check, and then we check if the key is not already in the queue. If key not in self dot queue, so we insert the key at the beginning of the queue to mark it as the most recently used. So we say self dot queue dot insert at the beginning, passing the value. So to ensure that the items in the queue are currently ordered by their LFU count, we call the move to end method to correctly position the key in the queue based on this LFU count. Let's just call the method, and then we go ahead and create the method, so we see what the method does. Like I said before, the method is going to reposition the element within the queue. So first we are going to determine the length of the queue. Say length. Determine the length of the queue. So for any key we need to reposition, we first find the index of the key in the queue. So we say in idx as index is equal to self.queue, dot index, and we pass in the key that we want to determine the index. This index represents the current position of the element in the queue. Next is we retrieve the count frequency of the key. Say key count is equal to self dot counter, and then the count reflects how frequently this element has been used. And then we are going to iterate through the queue starting from the current position, that is starting from the current index of the key. So we say for I in range, start from the index, and we are going to stop at the length. I mean, the goal is to find the right position for the key in the queue based on its LFU count compared to other elements. So again, inside this loop, if we have not gotten to the end of the counter, we say if I is not yet equal to the length equal to the length of this queue. So we first find the next key in the queue and its count. Let's say next equal to self dot queue plus 1, which is the next. And then we do this to check if the next key should appear before the current key or not. So we just say yes, see next count is equal to self dot counter, and we pass in next, which is next count. So if the LFU count of the next key is greater than the current key count, if the next is greater than the current key count, it means that the next key should be positioned to the left, indicating is used more frequently. So in this case, the loop is going to be terminated and the key is correctly inserted after the last key with a higher LFU count. So we break out of the loop, and then after the loop completes, we insert the key correctly positioned in the queue, ensuring that the elements with higher LFU counts appear before it. So we say self dot queue dot insert the key there. So the key is removed from its original position in the key, ensuring that there are no duplicates. So we remove the queue. Oh no, what about the spelling of this queue? Okay, we pass in key. So this move to end method, it plays a crucial role in maintaining the integrity of the LFU caching policy. It ensures that elements are positioned in the queue according to their LFU counts, allowing the cache to function correctly based on this policy. So now that we are done with the move to end method, let's finish up with the get method. So first we attempt to retrieve the item associated with the provided key from the catch data. So we say item is equal to self dot catch data dot get key. So we check if the item exists in the cache. If the item is, let's just check if the item is not done. That is, if it exists in the cache. If the item, if it is found in the cache, then we increment the count frequency of this key in the counter. So self dot counter, increment it. So this means that the key has been used again and its LFU count needs to be updated to reflect its increased usage. Again, we are going to call the move to the end method to correctly position the key in the queue based on its updated LFU count. So we call the method self dot move to end. Then we pass in key. So doing this ensures that the item is appropriately ordered in the queue based on how frequently it has been used. So finally, we return the item to the caller, or none if it's not in the cache. So already added this to the main test. Hoping there is no typo.